Good day, the Honorable Board of Panelists and the Honorable Audience. First of all, I would say thank you for your attendance and the opportunity we have here to present our research today of the spatial variation of current transport in Banda during ENSO period 1995 to 2019. My name is Frystine, representation of the Indonesian State College of Meteorology, Climatology, and Geophysics, and this is our presentation. Our research background start with the theory of the interaction of atmosphere and sea that state that interaction between two different fluids, which is the ocean and also atmosphere, is a complex and highly nonlinear process, and it is fundamental for the movement of the ocean and atmosphere itself. The three key variables of physical elements of oceans, which are the temperature, salinity, and ocean density, contribute to the interaction of the ocean and atmosphere itself. The variation in temperature, which is thermal, and salinity, which is haline in ocean, cause the variation of density that produce the ocean's current circulation called the thermohaline circulation. The thermohaline circulation that flow near the surface that passes through Indonesia called Arlindo. The bathymetry of the Banda Sea, which is the largest and deepest basin in Indonesia Sea, caused the two Arlindo inflows to Indonesia passing through the Banda Sea. The ENSO itself has an important influence on current transport in Banda Sea, which is associated with Arlindo, where the research of Yu et al. In 2020 find that the variability of Arlindo transport in Flores Sea route, where the Flores Sea route is the entrance path of Arlindo to Banda Sea, is dominated by the annual period, as the ENSO itself is a phenomenon in annual period. The meteorological viewpoint of ENSO phenomenon provide only little answer, so we also need to calculate the ocean condition parameter to more understand about the evolution of the ocean temperature anomaly oscillation phenomenon, and also the formation mechanism variability of that phenomenon too. The data we use in this research are the ONI index, Triton buoy observation data, and also the model data from the Copernicus Marine Environmental Surface for the current component of U and V. The depth of model data we use is the surface current data, where from surface to 4 meters depth. The data are processed by the CDO, GRADS, and CNN, and number processing software. Considering the bathymetry of the Banda Sea, we divided the research location into 9 grids, as seen in the figure and the coordinates. The dots here are the location of Triton buoy observation data, where the yellow point is the location of the buoy data that we use for the validation. The location is considering from the range of the availability of the data and also the resolution of the data. But for the analysis, we validate the model data first from the observation data. We use root mean square error and the coefficient correlation formula for the validation. The observation and model data depth for the validation we use can be seen in table 1. The correlation coefficient is interpreted by the Sugiono in 2003 method that can be seen in table 2. To identify the ENSO occurrence, we use the ONI index that also used by the BMKG as seen in table 3. To find the value of the current transport, we use the formula of QU from Atmadipura in 2017, where the QU is the estimated value of the volume transport in spare dome. The model validation showed that the root mean square error generally in the 4 points is less than 0.5. And the coefficient correlation showed the strong relationship where the value of the coefficient correlation generally in 4 points showed the value more than 0.6. The ENSO period is divided into 5 periods in this research, which are the strong El Nino, moderate El Nino, weak El Nino, moderate La Nina, and weak La Nina, where the occurrence time can be seen in table 4. The current transport analysis in this research is only carried on zonal currents because the meridional transport value that we have calculated in the Banda Sea is very small. This is due to the Banda Sea as a localized area, where the Thomas et al. In 2014 research explained that the spread transport in localized area has small value, so it needs to be averaged meridionally to get the movement of the water masses. From the figure 7, we can see that the variation of current transport in Banda Sea shows that the order from the largest to the smallest is from the Banda C, Banda F, Banda B, Banda E, Banda A, Banda G, Banda D, Banda H, and also Banda I. We can see that Banda C and Banda F has the largest transport values in each period, where the Banda C is the main Arlindo entrance, as we can see from the figure 5 and figure 3, and also Banda F itself is the Arlindo exit path. Banda H and I has the smallest transport value in each ENSO period, where Banda H and I is the location of the Weber Basin, where the Weber Basin has almost 6,000 meter depth, that it affects the water that flows within it, affect mixing process, so that it eliminates the water energy motion. The research of Diansky and Bagatinsky in 2019 showed that the movement of water masses can be indicated by a decrease in current transport from outside to inside, and also an increase in current transport from inside to outside. Where in this research, we can see that there are a decrease in current transport from the Arlindo entrance, which is Banda C, grid C, to the interior of the Banda C, which is the grid of Banda C, E, B, D, and also an increase in current transport from within Banda C to the Arlindo exit from the Banda C, which is from Banda H, E, to Banda F. The positive and negative value of current transport describe the direction of the current transport. In figure 7, we can see that the variation in current volume transport in 9 Banda C grids is varying in each ENSO periods, where generally we can see that the transport in La Nina period is larger than the transport in El Nino periods. We conclude that the Banda C and F has the most obvious pattern, that the increasing or decreasing of the current transport is associated with the increasing or decreasing of the intensity of ENSO itself. As BMKG is currently improving maritime information services by deploying Drifter and Buoy, research and variation in current transport in Banda C in ENSO period may be useful for further study of ENSO in Indonesia using marine parameters. By this research, we find that the variation of current transport in Banda C varies in each ENSO period in the 9 grids of Banda C. Above all, we aware that there are still a lack of our analysis. So next future research is needed to examine more specifically at one of Banda C grid to better understand about the variations. This is our references of our research. That's all of our presentations. We are really appreciate for the suggestion and credits for our next better research. Thank you for your attention. Good day.